Start recording. Okay, yeah, whenever you guys are ready, go ahead.
Yeah, so this is Jack's laptop over here, and these are the notes. So we write through our HDMI to NTSC adapter that we got. We write it to on-chip SRAM, write just the screen to on-chip SRAM, and then we have an FSM that looks at certain segments in the memory, and you can see that on the VGA. We can see that later.
Okay.
But we have like white boxes highlighting where we look. So this FSM controls the read address to the SRAM, so it's reading the correct pixels, and it also controls like a write enable like pixel data val to each of the note detectors, because you can see all the SRAM messages just go to all the note detectors. So the FSM controls which one actually like takes it in and says, oh, this is mine. So then we do note detection, and Jack will explain that with the colors in a bit. And then we also, so we detect if a color is seen, and we also detect where in a box, where in our box that we detected the color, so which line, which row we detected it on, and we send both of those things to the scheduler, and the scheduler says, okay, if there's a press, if it detected a color, I'm going to look at the edge height that it detected it at, and then schedule it for a certain number of cycles. So that's to just like count the weight between like when you actually detect the note and when you should press it.
Okay.
So then that goes into the keyboard controller, and the keyboard controller has a we call it a countdown queue. So whenever you on queue something with the scheduler, it goes into that countdown queue, and every cycle, all the entries in the countdown queue are decremented. So let's say we scheduled green for like a million cycles. Every cycle in this countdown queue, it's going to tick and decrement. And then once it gets to 0, we say, okay, it's time for us to press, and then we have a certain press time that we hold down a note for, and we send that to GPIO. And then I guess Kyle will talk about the circuit that we use then to press keys.
You do the color
Or you
first,
can
I'll
do
do
it
the
first.
hardware.
Okay, sure. So basically the top here is like the color profiles for all of the notes that we want to detect, and also white. So all these bars are RGB. And so green is pretty pure green, the red is pretty pure red, and then yellow is just like pure red and green. So those were pretty easy to do, and basically we apply these constraints to each of the note detectors so that they detect the color that we want. So for green, for example, we have like a minimum amount of green that we need to see, and then anything above that is okay. And then we have maximum amounts of red and blue, so that if it goes over that, we know that this isn't green and it's probably some white bar, because we noticed that the highway has like these like measure marks at like every downbeat that are white, and that was causing a lot of like overstrumming initially. So once we install like these maxes, so like the max blue that you're gonna see in green is actually really small, so we can set that down to like I think we have it at like 7 out of like 45 is like the 45 would be like if it was pure blue. So that keeps us from detecting white in the green area. And then the similar principles applied for red and yellow. Blue and orange are a little bit different though, because they have multiple colors in them. So blue, for example, is not a pure blue, it actually has some green in it. And so initially we were missing a lot of blue because we tried to set like the red and green maximum values together, but you can't really do that with blue because there's more green. And you actually need the red value to be low, because that's what prevents you from detecting white. So we couldn't raise it either, because then we'd overstrum a lot of blue. So we split those all up for each of the colors, and that gave us a lot more control over accurately detecting specific colors. And once we brought all of these signals out to PIOs, we were actually able to detect notes pretty cleanly with like minimal overstrumming. So
Yeah. Okay, so we come over here. So as Dylan mentioned, we write all the strums to GPIOs, which is how we control the keyboard. And then the keyboard is hooked up to Jack's laptop and is how you actually press the notes and strum. So what we do here is basically to press a button on the keyboard, it just shorts, there's like a few layers here, it shorts the top and the bottom layer. So to do that, to simulate that, we have these GPIOs write to the breadboard, which goes through resistor, and then to the optocouplers, and then the optocoupler consists of a diode and a photoresistor. So basically when we write to a GPIO, it turns on the diode, lowers the resistance of the photoresistor, and then that allows a short through the photoresistor, which connects the two pads. And then one restriction that our, I guess, contraption has is that since it's a USB keyboard, the way that this matrix is set up, such that whenever you press a button, there's actually multiple buttons on each sheet that are powered. So it looks at which ones are powered. So like on the top one there like could be, say, green, red, yellow powered, and on the bottom one there will just be green and blue and orange powered maybe. So the one in common there is green, so it knows that it's a green press. So this helps us a little bit because we could just use like one wire for all three of these. And we didn't need to glue them all because the gluing was getting a little messy. But one restriction of this is that you can only press 3 notes at a time for some combinations of notes. So as Jack drew on the board over there, with the circles, there were just green, red, yellow, blue, orange. And these are the combinations of colors that we can't detect. So for a green, red, yellow chord, we can't play that. Noxit doesn't see it just because the keyboard can't press it. So when you try to press green, red, yellow, and the strum key, it's too many keys and it won't support that. So we can actually play every other 3-note chord except these combinations.
So this is a limitation of the keyboard.
Yeah, that's
Yeah.
a hardware limitation.
Yeah.
That we,
I guess just did the USB keyboard too, because you can do it, like play it regularly on the laptop.
Okay.
Yeah.
Cool.
Yeah, should we play it through
Yeah, so let's start things on. Do you want to mention the switches?
Oh yeah, so we attached, so I guess the different switches, so this switch 0 we attached to like actually reading the video in there. So if that's off, like you can see, I guess we're
Yeah,
not
try
really
to
changing.
scroll.
Yeah, try to scroll. Yeah, so you see it doesn't change, and then if I turn this back on, it will change.
Okay.
Yeah, so, and then switch 1 is setting either 1-player or 2-player mode. So right now I have it in 1-player mode because just one person needs to play. So that lets us not have to recompile every time we want to like add someone in. And then the rest of the switches are connected to our box offset. So that's something we had initially to sort of be able to calibrate our device. So our idea was that, as I said before with the scheduler, it like kind of tells you, it creates a mapping of like how high you detected it in these boxes, and then translates that to some number of cycles. But we were thinking like, okay, we don't want to have to recompile every time. Like if we realize we're hitting too early, we don't want to have to recompile. So we brought some of those like an offset out to switches, where if we increase the offset, the notes would hit a little bit later. But what we found is that we were actually hitting perfectly. I guess we got lucky. We're hitting perfectly on time, so we didn't have to actually use that. So our box offset is 0 here.
Okay.
And then the hex display here, it shows you what notes you're pressing and if it's strumming or not. So right now it sees like a blue screen, so it's hitting blue. But yeah, so it's green, red, yellow, blue, orange, and then this is the strum key.
So as the song's playing, we'll see these sort of...
Yeah. And that's how we know we're hitting. It's detecting the chords that we can't play. We can see that it's seeing them correctly. It just can't play on the keyboard.
Okay.
Yeah. All right. So do we want to do single player?
Yeah, let's do 3 5 playing single player, and then we can play some songs 2-player.
Okay. So let me drop out, and then we'll just do this because we're set up for single player on the C code.
Yeah. And then as the song's running, you can see like where we're looking for.
Oh, wait, we're plugging in. Hold on.
What difficulty level is this?
This is
Expert.
expert.
Okay.
So
I think last time we got 96% on this.
okay.
Wow.
You can also see over here, it's detecting. So you saw right there, we had a chord that we actually physically can't hit.
Okay. Unreal.
It's
so-
so
it's so
sad when
underwhelming.
you can't hit those chords. 'Cause it's like a finishing note and then just doesn't hit it. You can also see over here we do our boxes. So like those boxes are what I was talking about with where we detect for each note. Those white boxes there, and you can kind of see the note. That's where we're drawing a little bit more just so we can
Yeah.
see the notes. But we only look in those white boxes
Okay.
from memory, and that's where we detect our notes.
And this is indicating the notes that it's seeing.
Yeah. So yeah, exactly. So on the hex display and on the LEDs, it's 1 if it's not detecting, A if it is detecting, and then the LED turns on.
Wow.
Another thing with this box is we calculated the box so that each note only, like one edge of a note only passes through the box at one time. So it's basically, the box height is how far a note moves in one frame.
Okay.
So that allows us to not like detect the same note twice.
Sure.
Yeah, so I guess some more restrictions of this that like might allow you to beat it is that it can't use star power, just because we use color to determine what notes to press, and when you use star power, all the notes turn blue,
Okay.
which is pretty unfortunate because it's like a score multiplier.
Yeah.
So that's like one little edge a human can get on it. Also the chords that we mentioned before that it can't play, and then on some held notes like that, since the bar is such a pure color, it'll look at that and think there's a note there, so it'll double strum
Okay.
Like
and
that,
throw your
there,
streak.
And that.
So it doesn't really affect your percentage, but it does affect your score.
What are the best streaks that you're seeing?
It depends on the song. We'll see at the end.
Yeah.
We saw a streak of 550 on this song to begin the song.
I have.
Yeah,
we
you're-
have 5. Our max is 556 right now for this song. Let's see.
Now you're trying to get another 500
There's 500,
streak,
yeah.
right?
I think everything else is under that. But that's because this song has a lot of like strings of notes without like the held notes,
Sure.
which makes you break the streak. So
I think on average though, like usually there's a streak of like at least 75 to
Yeah.
150.
Yeah.
Yeah, we found that we're usually getting like around 98% from most songs. One song we just did, we got 80%, but that was because the song had a ton of the chords that we can't play.
yeah,
Like,
so
half
we
the
kind
notes
of
were
did that on purpose.
Okay.
Just wanted to see.
But yeah, the parts that weren't the chords that we can't play did very well on.
Forgot which one high score is on. That was my high score.
So,
Yeah, we're losing a lot of high scores because it's breaking down.
Because it's beating him.
yeah.
I'm gonna have to put an asterisk next to this.
Wow.
Yeah, we've been playing against it for a few different songs to see how we stack up against it, and we can beat it sometimes, but only for certain songs.
Yeah, not on this song. On like really easy songs where like me or Jack can get like 99%, then we can beat it because we can keep the streak longer because we can do held notes and
Yeah.
we can also use star power.
Yeah, sure.
Which is like a double multiplier. So
Yeah, which almost makes it more fun. Because it'll destroy you percentage-wise, usually like percent of notes hit, but if you're smart, you can beat it with score
Okay.
for some songs.
see, that's just kind of sad.
Very underwhelming.
That's too fast for him.
then. Check in.
Yeah.
Check for short amount of time.
Unreal.
So,
Awesome. Thank you guys.
Yeah, and the reason we unplug the keyboard is because once we get to this, it'll like start pressing buttons.
we'll start pressing
Instead of
blue, and then it'll go into practice mode.
Okay.
But that was
Before,
96%.
before it was hitting yellow,
Highest
and we were
streak
like,
of
it kept like
304.
replaying the same song. Well, it was hitting yellow because our like this was before our keys were all working. So like,
Really
and we were
cool.
like, it keeps replaying the song. It's because the yellow is the replay button. Like, I don't think we started it.
Cool.
Try 2-player.
Yeah. Yeah. So let's
Here, let me see.
let's get the key code to the 2-player, and then let's see. Is there a song that you?
Yeah, so changing the
playing?
switch, all it does is it just changes where you look in memory. So if you
Sure.
saw, like, it changed. So if I actually switch this, oh wait, sorry, we're running a C, but this is where the C program is like looking at.
Okay.
It, so it lines up with where we actually are looking.
This is a good song, I think, to do. All right.
So now it's man versus machine.
Yep. Okay. So the FPGA is on the left side. Oh wait, I forgot to turn the volume back on, sorry. Okay.
You said FPGA is on the left?
Yes.
For those notes with white on the top, a human, you don't have to strum every one of them. You only need to strum the first one, and if you hit that, you can just tap the rest of them.
Okay.
So it actually makes it harder for the FPGA. Like, it's supposed to be harder if you can't just tap those. It's a little easier for the FPGA to see it because there's more color.
So we actually turn that off for the FPGA. So you'll notice on the left side that they don't have the like white caps.
Right.
And that's just to help with that color detection. Just want to keep it consistent. All
Yeah.
the be the same colors.
But you can set that like by account. So when you make like an FPGA player, you don't have to change it every time. You can just set it once. Yeah, so here Jack has star power turned on, and he has a streak, so it's until then he had a score of a streak of multiplier 8. There's an opportunity to pass the FPGA.
Yeah, so you can see like on easier songs.
Yeah.
Easier to see the fire close. Like Jack can hit a streak, you can't hit star power and FPGAs. Like it might get a similar percentage Jack, but it's gonna lose its score.
It will beat me though because of this.
Oh yeah. Another thing we had was, if you look over here, when it hits a note, you can see there's flames that go
Yeah.
up. So initially we had our box being drawn lower, so we were looking at a lower location of memory. But we found that the flames were actually like interfering with
Sure.
it was in the box. So like one option we had was to turn the flames off, but that's not as fun. So instead we just moved the box up.
Cool.
Without the flames, it's kind of hard to tell when you press it. Like the note will disappear and it won't drop below the
Yeah.
note line, but like it's not as satisfying. That's how you can really see that you hit it.
That's really cool.
Yeah. I think it's today, right?
That's
What do you think? Think you got it?
No.
Oh, I actually beat its
Ooh.
score.
So you got a higher score, we got 9% more than you.
So we got 98%, but you got 89%.
cool.
You beat by
Edged
9,000.
out, yeah.
Awesome.
Yeah.